Okay, again, as you guys are writing, if I tell you to put something on the ultra lava, then some people like to put it in their notes and on your ultra lavas, so your choice. If you've got different colors that might help explain it, I'll explain it in a second, and we'll do some examples. So last week I told you guys that I wanted your thoughts on like the term 1 test, and I was going to put a poll on Canvas, then forgot to press publish. Did anybody go on Canvas? And we're like, what? Okay, so yeah, I'm a weirdo. I do things like that. In the future, feel free to shoot me an email and be like, Summers. But anyway, it's up now. So it's a 1-question poll. I just would like to know what you feel about doing or testing this term. So if basically the reason I'm asking now is because next class we're going to move on to how limits apply to derivatives. We're wrapping up our limits unit. So if you guys are going to prefer smaller tests more often with a little less remediation opportunity, then we might have a test coming up. Then the other option is 1 larger test with more remediation at the end of the term. And the third option is, I don't care, just tell me what it is so I can put it in my planner, okay? So if you can go on there sometime tonight, you'll probably have time at the end of class today as well, okay? So just keep that in mind. I remembered to press publish when my A2 class reminded me. So.
Why would it be 9? Wait, it's A, right?
Yeah, it's A.
X approaches A.
Yeah.
That's A.
Arbitrary. I've been trying to learn that word for 3 days. Arbitrary. Wow, finally. So in these math theorems, here's where I'm going to be using this word. We use this kind of coordinate point, lowercase a, capital L, as like a arbitrary coordinate point, meaning it doesn't really matter where it is, it's just some random coordinate point somewhere. Okay. Good? Okay, the squeeze theorem. So here's the idea. I have some group of functions where I know that their y coordinates, like g of x is always going to be smaller than or equal to f is always smaller than or equal to h. So that's kind of shown here, right? It's like g is like our lower function, f is our middle, and h is our top function, right? And the limit as x approaches a of g of x and h of x for some a value are the same, okay? That's what this is showing here. But the squeeze theorem says that then, even if I don't really know f, okay, I know though that because these limits are the same, that this one's going to have to bottleneck and also have that same limit there as well. That's what the squeeze theorem is saying. Okay, any questions? We're going to do a couple example problems. Any questions? Okay. You know it's a fancy formula when I come up with my examples, right guys? Oh yeah. Oh, I know.
I love the word
It was like a little bit.
You guys writing?
Yeah.
Wednesday, so we're trying to save time.
Well, when I supposed to earlier, so.
No pre-thought of examples.
So she already knew.
I'm still writing this.
Well,
That's on. Is that
9, 4, 10.
Thank you.
So in an if-then statement, okay, the conditions are everything after the if, before the then, okay? So the first thing we need to do is verify that all of our conditions for the squeeze theorem have been met, okay? So this first condition has been met, right? That's a given. Make sense? Okay? Now, one thing I want you guys to get in the habit of, okay, don't freak out when I say this, just hang on with me till I finish the thought, okay? I want you to think about some of these more formal theorems when you're answering questions about them. Think of it kind of like a two-column proof. I'm not saying we're doing two-column proofs, okay? What I'm saying is that sometimes, even though it's like, well, yeah, duh, like I feel like I should just be able to do something like that, right? You want to imagine it more like I'm formally talking about it. I want to use the vocab, I want to use the language, I want to use the notation. So when you answer these kind of free response questions, which is like a short answer question on an AP test, we call them FRQs. Just imagine it kind of like a two-column proof in terms of the formality of it, using the vocab, not doing anything in your head, okay? So as I'm looking here, I say, okay, well, this first condition is kind of like a given, right? But this second condition, I need to find out if that's true, okay? So I need to find out if the limit as x approaches a of g of x is the same as the limit as x approaches a of h of x. What's the a for our problem? What a am I using? 1, good. Because that's what the question is asking about, so that has to be the one I'm trying to find, right? So then I'm going to go, okay, what's the limit as x approaches 1 of g of x? Well, I know with limits, I start by taking the value and plugging it in to see what happens, right? So tangent of pi fourths times 1. I don't know why I got rid of those parentheses. What's the tangent of pi fourths? That wasn't a very confident one. Is that what it is? 1 plus 4, so 5. Of h of x. Now,
No, I was real. They both have their practices. How it's like. So I just wanted to do the one that was easier.
so does it satisfy both conditions for the squeeze theorem? Yeah, right? The one was given and the other one, I showed my work, I used my notation, and I found that both of these limits were the same at x equal as x approaches a, and they're both 5. So that tells me that this one is also 5. And I know that even though I don't know what f of x is, it doesn't matter, right? So to formally answer, I'd say, okay, by the squeeze theorem, your guys' favorite word, the limit as x approaches 1 of f of x equals 5. Okay? Now this only works as my answer with this attached work, right? You wouldn't get full points on a free response, short answer, if you just had that sentence, because they're saying, okay, you're using the squeeze theorem, but you didn't even show me all the conditions for the squeeze theorem are met, okay? One thing you guys are going to notice that I kind of like drill in your brains, like not using it, right, being specific about when you say, well, that thing is there, and I'm like, well, what's that thing and where is it going, right? So one of the reasons for that is as an AP teacher at the end of the year, we get like our scores back, but we also get a breakdown of what things our students really did well on and what they really struggled with. In the last couple of years, one of the things that my students have struggled with is they haven't been specific in their vocab, in their explanations. So right from the beginning, you probably already noticed I'm drilling being specific from the beginning, right? So anytime you guys use the word it when you're answering a question, I like yell at you, right? Okay, so we're gonna get in the habit of answering our questions with that as well. We wanna make sure we're using vocabulary and being specific. Especially because don't you think this is easier than some of the stuff we were doing last class, right? So just it just don't get lazy with how you're writing it out on these easier questions, okay? Any questions before I give you guys one to try with your neighbors?
So you have to show both, or can you just do like one?
Sorry.
Oh,
Yeah, I have to show both of the limits. Yeah, because the only reason that it works is if the top and bottom limit are the same. That's what's making this bottleneck and also be the same.
And you also have to be told,
That's what I'm doing, I'm proving.
You also have to be told f of x is in between the other two, right?
I have to be told that as well, or I'd have to show it by graphically showing that. Okay? Good. Anyone else? Okay, I got another one for you. So I'm gonna have you guys try with your neighbor friends. What am I looking for? Marker? That'll work. Okay. I'm like spaz attack. Okay. All right. Okay, notice I got rid of the restricted domain in the question 2. What that means is a couple things. The first one, it was needed because of the tangent has asymptotes, so I restricted the domain to not include those asymptotes, okay? The other reason it was needed is that on those equations, it's not like the tangent was above the quadratic or the cubic or whatever the whole time. But it's not needed on this one because the one quadratic is always going to be above and the other one's always going to be below. So I could have picked any A value to use for this, okay? So basically it's saying that this is true for everywhere in the domain because it doesn't have that between -1 and 2 like the last one had, okay? Yeah. Okay, try this with your neighbors.
So yeah. I guess because there's the
Oh. Is it the same club that he had, do you know? Yeah.
Wait, is that 1.5 or 11 halves?
11 halves.
So we're gonna.
Okay, another 30 seconds or a minute. Please make sure you're answering it formally.
No squeeze on this one.
Squeeze is 0. Squeeze is very 36.
I like max.
Yeah, that's 5. Yeah, so -1/2. That's what it is. Yeah.
Chase, I wrote it in my notes. That's pretty cool. Congrats.
Yeah.
Okay.
Oh yeah.
You guys need more time? Okay. So first I'm going to go through and see if the conditions for the squeeze theorem, your guys' favorite word now. I think I heard some of you say the squozed theorem or something.
Wait, I have a question.
Sure.
So when it says if f of x satisfies that, is it saying that they're giving us that, but you have
Yes.
to make sure it does fit that? Okay.
Yeah, I don't have to make sure it fits this. I'm saying if I know this is true, then find this. Okay? So then the limit as x approaches 1 of g of x is going to end up being, you guys showed your work better than me, I hope, 3.
Yeah.
And the limit as nothing in your head, so even that work, get it written out, is 5. So now here's where you have to be careful, okay? Because the idea of me being able to find this limit is not a mutually exclusive idea. Do you guys know what that word means? Mutually exclusive. So it's like two things that can't happen at the same time, right? So it's like it's not like I can either find this or I can't find this. It's I can either find this with the squeeze theorem, I can find it, I can't find it with the squeeze theorem, but then maybe that doesn't mean I couldn't find it, it just means I can't find it with the squeeze theorem. So be careful in how you wrote, because if you wrote something like can't be found or does not exist, that's not necessarily true. It just means that our A value is somewhere, like if this is G, this is H, and then our F is in here, it just means that they don't actually touch at that point, right? Right, it's just somewhere between 3 and 5. So what I'm saying, the idea is more along the lines of not enough information to use the squeeze theorem, okay?
But it does give you a general idea, right?
Right, but I can't find it exactly. Right. That's exactly what I would say. I would say not enough info to use squeeze theorem. Right? Because if I say does not exist, the problem is that limit might exist. I just don't have enough information to find it right now. That's the idea. Okay? But notice I'm still showing my work. I'm still being formal, and I'm still using my vocabulary. Okay? Good? Okay, questions? Okay, last thing. Formal definition of continuity. I have it written there in brown. So that's another one for ultra lavas and or notes. So I'll give you 30 seconds to write that, and then we'll talk about it. Yeah, last thing for today. Formal definition of continuity. So what I have written there in brown. Okay, so take that. So it definitely needs to go on your very important topics list, and then I got distracted by pictures of my cute baby. I'll be real. I don't know what I was saying, but you guys are working, so it sounds like you guys know what I was saying. It's great. You trained well. Update this wall. This girl, look, she just turned 10. My niece, whoops. She just turned 13. He's driving. I need to update my wall.
Stinko.
I should take a picture of that picture and send it to him and his friends' phones. My nephew, so. You guys need more time to write? We'll fill it front and back by the end. But usually around January, most of my students like to try rewriting it anyway, just because the more you write it, the more it helps you memorize it anyway, so you can reorganize then. Yeah, exactly. Okay. Formal continuity. So hopefully this idea actually is pretty familiar from what we've been talking about, right? Continuity, we're saying the limit exists, and we've already said that the limit only exists if the left and the right-hand side, I said left and right, but really it's left and right? Okay, are the same, and then the value is also the same there. So this formally should make sense with what we've been discussing. Is that fair? Okay, so what really I'm practicing with this is answering questions in an AP kind of a way. Okay, so we're just going to do one example together. Just to go through how to do it, and then I'll explain your homework tonight. It's our first one on AP Classroom, and I just want to explain a few things about how those ones are going to work. Okay? So, let's say I had f of x is this. Okay, couple things that would earn 0 points on an AP test. Yes. If that's your answer to this question. Is that the correct answer to this question? Yes. But what, you're not showing any of your thinking, you're not being formal enough. Yes, okay, great, right? So again, these are, I think, some of the easier continuity things. I mean, this is way easier than that one I did on your homework questions today, right? But what we're doing again is we're practicing the formality of answering these AP questions from the beginning so that this year I don't get that report back like I did last year and the year before, right? Okay, so I have to address all conditions of the statement. So first thing I'm going to do is I'm going to address this. So the limit as x approaches to positive of f of x. Here's a sad thing I've noticed that people get marked wrong on AP tests. Yeah, because it's like leaving an open square root, right? Think of this like an operator. It's technically not, but that's how I want you to imagine it, like an operator. I wouldn't just leave this as an answer, right? Or part of my work. This doesn't have any meaning unless there's a number in it.